Good afternoon, students. So, whether my screen is visible, I am audible.
Yes, sir.
Okay, right. So, good afternoon, students. So, welcome to the module 30, right, for the IC engine subject, right. So, we are in the fourth unit, right. So, the cooling and the lubrication systems in the IC engine, right. So, in this class, we are going to see what is lubricant and types of the lubricating oils, right. So before seeing this lubricant and the types of lubricating oils, just we can recap what we discussed in last class. So the lubrication system, right. So the lubrication systems, right, why we have to use the lubricants, right. So in the machine or engine, right, so we have plenty of the machine components, right. So that machine components will make the surface and it may have some relative motion between them, right. So uh, the friction, right. So while it is in working condition, right, due to the relative motion between the machine components, there may be a chance, right. So it may have some frictional force, right. So due to the frictional force, the heat, it will develop the heat, and it may have some wear and the tear conditions, right. So the engine components life or the machine components life will get reduced, right. So we have to avoid these conditions, right. We have to avoid these conditions. So the lubricating system will be introduced there, right. So what are the functions of the lubricating system, right. So the lubricating systems, right, so it will avoid, right, it will reduce the frictional force which is acting on two mating surfaces or relative motion between the machine components, right. So once the frictional force is reduces, automatically what it will reduces the wear and the tear, right. So where the rubbing will be occurs, right. So thereby the heat generated also reduces, right. Then the power output, right, it will not affect the power output, so the losses may be a controllable one, right. So this is the main function for the lubricating systems. And the lubricants or coolants, right. So lubricants, it act as a coolant, right. So anyway the heat will be generated due to the frictional force, right. So that heat may be dissipated by the lubricating systems, right. And the due to the combustion process, it may have some contaminations in the engine, right. So the lubricating oil clean that contaminations also, right. So it will work as a cleaner, right. So the lubricant is work as a coolant, and the lubricant is work as the cleaner, and it will form a good seal between the piston rings and the cylinders, piston rings and the cylinders, right. And it will reduce the noise, right. It will reduce the noise, right. Generally in the engine, how the noise will be created means we have plenty of the vibrating elements, right. So due to the vibration we can get a noise, right. So that noise will be reduced by means of the lubricating system, right. So if the lubrication will be there means there is small very the frequency will be very low for the vibration, so we can reduce the noise which is produced by the engine or a machine elements, right. So these are the functions of the lubricating systems. And the engine parts, right. So what are the parts we have to lubricate, right. So that parts, right. So most of the engine parts will be have to lubricate, right. So most of the engine parts will have the motions, right. So it will have some elements, right. So here you can see the valves, right. So in this valve itself, so valve, spring, and the rocker arm and the cam, right. So these four, right? So the valve, the spring, the rocker arm, and the camshaft, right? So here we have to supply some lubricating oil. So here we can reduce the frictional losses and the heat developed due to the frictional losses, right? So then some lubricating will be splashed into the crankcase, right? So in this crankcase, so the crank shaft will have some relative motion, right? So then the piston will be moves from TDC to BDC, BDC to TDC. So relatively it will have some motions, right? So the cylinder wall and the piston rings, will have some mating surfaces, right? So between these two, we have to supply some lubricating oils. Then the connecting rod and the crankshaft, right? So the piston will be connected through the connecting rod and the crank, right? So there some will have some relative motion, right? So these elements will have the lubricating terms, right? So these are the parts, these are the engine parts which we have to lubricate, right? Then lubricants, right? So we have to lubricate, okay, right? Then what is the lubricant, right? So it will reduce the friction between the mating surfaces by replacing the solid friction into the fluid friction, right? So that term is called the lubricant. That term is called the lubricant, right? So then the lubricant or a agent, right? So lubricant or the agent, it introduced between the two mating surfaces, or in the relative motion, it will minimize the friction, right? It will minimize the friction by replacing the solid friction with the fluid friction, right? So the selection and the application of the lubricant are determined by some functions, right? And some functions that may be expected to perform good, right? So what are the functions, right? So these are the functions you can see here. So these are the functions, right? The functions of the lubricants are to control the friction, to control the wear, it will control the temperature, and it will control the corrosion, and it will remove some contaminations, and it may give some good form of the seal, right? So it may have these functions, right? So the selection and the application of the lubricant are determined by these functions of the lubrication, which will expect to perform in a good manner, right? So then the types of the lubricants, right? We have uh, majorly three types of lubricant. One is the liquid lubricant and quastic solid lubricant and the solid lubricants, right? So we have three types of the lubricants, right? So in this liquid lubrication, we have the three subdivisions, right? So plain mineral oil and with the addition of the additives and the synthetic lubricants, right? So the depending upon the typical applications of the requirement, we have to use the particular type of the lubricant. So whether we have to use the solid lubricant, or we have to use the quasi solid lubricants, or a liquid lubricants, right? In the particularly in the liquid lubricants, so which we have to use, right? So whether we have to use the plain mineral oil, or the mineral oil with the additives, or a synthetic lubricants, right? So these and all depends on the application requirements. So these and all the application requirements, right? Then first we can see what is the liquid lubricants. So the liquid or generally preferred for the lubricants, right? So most of terms we have to prefer the liquid terms, right? So why? Because here we mentioned we have to minimize the friction, right? So we have to reduce the friction, right? So we have to reduce the friction to minimum to the minimum level by replacing the solid friction into the fluid friction. So we have to convert whatever may be the friction, we have to convert with the fluid friction. So most probably we have to prefer the fluid frictions, right? So in the fluid friction, we are mostly using the liquid lubricants, right? So the liquid or the general preferred one, right? The liquid lubricants or the generally preferred one for the lubricating purpose, for the lubricants, right? So because they have drawn between the moving parts, right? So they have drawn in between the moving parts of an hydraulic action, right? Hydraulic action, we can supply some liquid, liquid lubricants. So it's very easy to supply, right? So whatever may be the complexing shape, right? But we can supply the liquid, we can supply the liquid. Why? Because it will occupy the shapes, right? It will occupy the shapes, right? So this is the specialty of the liquid lubricants. So wherever we can supply this type of the liquid lubricants, right? So apart from the keeping the parts separated, they are also act as a heat carrier, right? So these are the special for the liquid lubricants, right? So the liquids are generally preferred for the lubricants. Why? Because it will drawn between the moving parts by the hydraulic action. Then it will, apart from the keeping the parts separated, they are also act as a heat carriers, right? So in this chart for the given applications requirements, right? So this is the primarily consideration of the liquid lubricants, right? So the effect of the temperature change on the viscosity should be minimum in the liquid, right? So if the temperature will be increases, right? So what about the liquid's viscosity? It may drops, right? So the liquid lubricants should be have uh, greater inert towards the metal surface and the other components, right? So these are the special for the liquid lubricants, right? So in this liquid lubricants we have sub classification or subdivision of these three, right? So one is the plain mineral oil, right? And the second one is the mineral oil with additives, right? So with additives we can use. Then we have the synthetic, the lubricants, right? So first we can see the mineral oils, that is a plain mineral oils, right? So for the uh, what do you say, the modern refining technology, the technicians has made it is possible to produce the lubricants from the crude oil, right? So right, right. Sorry for the inconvenience. So whether my screen is visible, I am audible.
Yes, sir. Audible, sir.
Okay, right, fine. So first we can see about the mineral oils, right? So for the modern refining technologies, the technicians has made it possible, right, to produce the lubricants of the good quality from the wide variety of the crude oils, right? So whatever may be the liquid terms, right? So the source is the crude oil, right? So it may be have some refinery, we can get different type of the products, right? So petrol, diesel, kerosenes, then oils, lubricating oils, right? So we have to get the we have to get we have to produce the lubricants from the crude oil, right? Then we have some refinery process, right? So in the refinery process we can get the plenty of variety of the products, right? So here we can get a good quality, that also by the very good refining process, right? So for the refining of the crude oil process of the separating the crude oil into the different fractions, different cuts, right? So these cuts all form of the naphthalines, gasolines, diesel, petrol, and the light oils or heavy oils, right? So we can get the different type of the materials, different type of the products from the crude oil, right? So we can get the mineral oils from the crude oil, right? So that type of oil will be used for liquid lubricants, right? So the mineral oils, right? So which is produced from the crude oil refinery process, right? So in that refinery process, we can get the plenty of the product, wide range of the product. So different temperatures, right? So in the refinery process, we have the different temperature ranges. Depending upon the temperature ranges, we can get the different type of the products, right? So in this form, we can get the mineral oils from the crude oil, right? So most of the terms in the mineral oils, right? What are the mineral oils we can use from the crude oil means we have used most of times in the two types of the oils, right? So one is the paraffinic oils and second one is the naphthalic oils, right? So paraffinic and the naphthalic oils we can use, right? So then the second one is the mineral oil and some additives, right? With some additives, right? Mineral oils plus the additives, right? So the refinery makes only the base lube oil, right? So in the refinery process, right? In the refinery process, we can get, right, the base lube oil stocks in the different viscosity levels, right? Different viscosity levels we can obtain the mineral oils, right? So they are unsuitable for the direct consumption, right? So we can't use these type of the mineral oils in some requirements, some application we can't use in the direct consumption, direct manner, right? So therefore the oil will need some mixed condition, right? So the oils are mixed to attain the right viscosity, right? So the viscosity is the important characteristics of the any liquid or any fluid, right? So the viscosity will affect, right? It will resist the flow, right? It will resist the flow, right? So the viscosity is a very important characteristics, right, for the lubricant, right? So uh, in the refinery process we can get a lubricant from the crude oil, we can get the minerals from the crude oil, right? So in some a specific or some particular applications we can't use the mineral oil in a direct manner, right? So the viscosity is not sufficient, right? The viscosity is not sufficient. So on that condition uh, we have to change, we have to attain the right viscosity of the particular mineral oil. So we have to add some elements, right? So that element is called the additives, right? That will improve the quality of the lubricants, right? So that type of the mineral oils will be used in a particular application, right? So that term is called the mineral oils plus we have to use some additives, right? Then the third one is the synthetic lubricants and third one is the synthetic lubricants, right? So in that synthetic lubricants, right, can be characterized as a oily or a natural liquids, right? So they are not obtained from the petroleum crude oils, right? But we can manufacture in artificial method, right? So uh, this type of the liquid lubricants, right? So this type of the liquid lubricants is called the synthetic liquid lubricants, right? So it will not produced from the petroleum product, that is the crude oil, right? It is not produced from the crude oil, but it may have the same properties, but it may have some same properties which is produced by the crude oil lubricants, which is produced by the uh, lubricant produced from the crude oil, right? So uh, it will its requirement will have some different type of the applications, right? So for the specific the chemical classes and the synthetic lubricants or the esters, right? Most of the time the esters will be used for the synthetic lubricants, right? So synthetic lubricants is the artificial lubricants, right? So it's a liquid it's a one type of the liquid lubricants. Then the before seeing the second one, the quasi solid lubricants, first we can see the solid lubricants, right? Then it will be easy, right? So you may know what is the grease, right? It's a semi-solid one, right? So grease is a, it's not a liquid, it's not a solid, but it is a semi-pasty form, of the lubricant. So it is called as the quasi solid lubricant. So first we can see the what is solid lubricant. Say a solid lubricant is a thin film of the solid, right? It is interposed between the two mating surfaces, interposed between the two mating surfaces to reduce the friction and the wear, right? So that type of the lubricant is called the solid lubricant. It's a thin film of the solid, right? It is a thin film of solid, right? So which is imposed between the two rubbing um, surfaces, right? So most of the time you can see the washers, right? uh, Gaskets, then the washers, right? So these are also used as a lubricant, right? So it will have some thin films, right? So it will be imposed between the mating surfaces, it will be imposed by it is imposed between the two surfaces, mating surfaces, right? Rubbing surfaces. It will reduce the friction and the wear, right? So the need for the solid lubricants has grown rapidly with the advanced in the technology, right? So most of times, uh, so nowadays we are using most of times in the solid lubricant, right? So the solid lubricants will have some characteristics, right? What are the characteristics? Low shear strength, then the low hardness, then high addition materials, and the continuity, so self-healing abilities, and then the thermal stability, then the chemical intenseness, right? So these are all the characteristics of these solid lubricants, right? So the types of the solids, right? The types of the lubricants, right? So we have three types of lubricants. One is the liquid, the quasi-solid, and the solids, right? So these three types of lubricants will be available, right? So what are maybe the lubricants, right? That lubricants will have some properties, right? So due to the property, we have to choose whether it will be suitable for the particular application or not, right? So these five are the major properties, right? These five are the major properties to see whether the lubricant will be suitable for the particular application or not. So these are the five properties. So we are telling that it is a characteristics, right? So lubricant characteristics, right? So these five, so already you know, right? So what is the specific criteria? Already these terms will be familiar to all, right? Whether it is familiar to all or not, right? So what is the specific gravity? Anyone? What is the specific gravity? Anyone? Specific gravity. யாராவது இருக்கியா கிளாஸ்ல இருக்கீங்களா? முகேஷ், முகேஷ் டி. முகேஷ். So if you are not replying means I put absent. There is no option to go. Right. Then Jyoti Shankar.
Sir,
Jyoti Shankar, what is specific gravity? என்ன ஜோதி சங்கர் தெரியுமா தெரியாதா?
no, sir.
Right. So the specific gravity is a ratio, right, between the densities, right? Ratio between the densities, right? So densities means whatever may be the liquid, right? Whatever may be the lubricant which you have used for the particular application for the lubrication process, right? So its density is very important one, right? So the specific gravity, right? So the specific gravity is the ratio between the density of the particular lubricant and it will be compared to the standard liquids, standard fluids density, right? So for example, if you are using the liquid, right? If you are using the liquid lubricants, right? So for the standard liquid will be the water, right? So it will be divided by the water's density, right? So water may be the lubricant, right? So the specific gravity first we have to see, right? So the specific gravity, the first characteristics, right? It is the density ratio, right? Specific gravity is the density ratio, right? So it will be denoted by the S. Then the second one, what is the viscosity, right? So what is viscosity? It is also a measure of the fluid, right? It is also a measure of the fluid which is resistance to flow, right? Which is resistance to flow, right? So the you have know what is the Newton's law of viscosity, right? So have you remember that one? Newton's law of viscosity. So du by dy. அப்ப இதெல்லாம் ஞாபகம் இருக்கா இது எல்லாருக்கும் ஞாபகம் இருக்கா? So the viscosity will have two viscosities. One is the dynamic viscosity and second one is the kinematic viscosity, right? So the stress, right? So for example, if we have a pot, we have two mating surfaces, right? So one is the movable surface and one more is the fixed surface, right? So here we have some lubricating oil between the surfaces, right? We have lubricating oil between the two surfaces, right? So if the parts will have some relative motion, right? If the part will have some relative motion, right? So we have to apply some force, right? From the top of the any one product, right? Any one part, right? So what will happen? So it will move, right? It will move in this direction and a particular velocity, right? It will move from the particular velocity. So what will happen? So the lubricating film, right, will resist the flow, right? So it will have some protection, right, between these two, right? So what will happen? So here it will reduce the noise, right? So it will reduce the vibration, right? So what will happen? So it will be moves in a smooth manner, right? So while it will be moves in the smooth manner, so how the curvature will be? So it will be like this, right? So the velocity profile will be like this, right? So here the velocity will be high and it will be zero at the mating surface, right? So the viscosity is a very important one, right? So the viscosity is a very important one for the lubricating purpose, right? So either it may be a liquid or a fluid, gas, right? So the viscosity is a very important one, right? So here we have the two type of viscosity. One is kinetic viscosity and dynamic viscosity. So the mu will be represented by represented as a dynamic viscosity and mu will be represented as a kinematic viscosity, right? So it will be denoted by the unit of stroke, and here it will be denoted by the unit of poise, right? So it will be denoted as the unit of poise or the Newton second per meter squared, or here it will be centimeter squared per second, right? So these are the units will be used for the viscosity. So the viscosity is a very important property, right? Viscosity is a very important property, right? So for the ideal oil films, right, the bearings depend upon the selecting of the particular oil, right? So which have some right viscosity or not, right? Which have some right viscosity or not, right? So the viscosity is a very important one, right? So why? Because uh, we are moving for the additives, right? The mineral soil with the additives, right? Why we have to use additives means we have to attain the right viscosity, right? We have to attain the right viscosity of the particular liquid, right? So we have to use some additives, right? Then only we can use as a lubricant, right? Then only the fluid will have some viscosity, so it will have some good uh, resistance to flow, right? So the viscosity has to attain, right? So this type of viscosity, right? So this the additives will be used for the mineral oils, right? Why? Because the viscosity we have to attain. So the viscosity is a very important characteristics of the any lubricant, right? So that we have to see, right? Then the viscosity index, right? So the viscosity will be expression, right? It will have some effect on the temperatures, right? So the viscosity may vary depends upon the temperature, right? So for the liquid if the temperature will be rises, right, then the viscosity will be reduces. For the gases, what will happen? If the temperature will be increases, then the viscosity also increases, right? So the effect of the temperature on the viscosity, right? So it will be expressed in the term of the viscosity index, right? So the viscosity and the viscosity index, right? So these two are the very important one for the characteristics of the lubricant, right? So these two is a very important characteristics of the lubricant, viscosity and the viscosity index. Then the fourth one is the pour point, right? So what is the pour point? The pour point of an oil, it's an important quality, right? So it's the temperature at which the lubricant, right, will still remains as a fluid, right? So it will not change its phase, right? So still it is in the uh, liquid form, or still it is in the gaseous form, right? It will not change its phase, right? So at the temperature, so whatever may be the material, right, at the particular temperature, what will happen? So for example, if the lubricant will have will be heated, so at the particular time it will be stable as a liquid, right? So beyond the temperature level, what will happen? It will be evaporates and it will be vaporizes, right? So the temperature, right, so where the temperature it will change its phases, right? That point is called the pour point. That point is called the pour point, right? It is the temperature at which the particular lubricant will still remains in a its phase, right? So that point is called the pour point. Then the flash point is a very important one. Why? Because the temperature, right? So if the temperature will be increases, keep on increases in the engine, right? So on the time, what will happen? The fluid, the lubricant will get some uh, fire. It gets some fired, right? So we can avoid that type of the lubricants, right? So we have to add some other additives to avoid the to burning of the liquids, burning of the lubricant, right? So the flash point we have to know, right? So whether the temperature at which the lubricant uh, gives of the sufficient vapor, right? So which can be ignited, so that we have to see. The flash point is a important one, right? So it will reflect on the capability or of the lubricant to work at the higher temperature or without any fire hazard, right? So that we have to see, right? So these five are the important characteristics or important properties, you know, so which we have to use, right? Which type of the lubricant we have to see, right? So these are all the five terms, right? These are all the five terms of the characteristics of the any lubricant which we have used for the particular applications, right? Then we have some additives, right? So why we have to use some additives, right? So the additives will be used to get for the particular viscosity attainment, right? Viscosity attainment, we have to use some some of the additives, right? So that we can see in the next class, right? So what is the additives and what is the purpose of and what are the properties of the additives, that we can see in the next class, right? So uh, so for the lubricate, right, for the lubricating we are going in the very slow manner, right? So why? Because it's a very simple unit, so the unit coverage will be